Hello and welcome back to another fine evening of Rust with me and, well, official edA-qa. He was actually on the show before I made it online, so glad to have you back, edA-qa. Glad you could make it. We're still playing with Bomberman right now. Oh, we have a notification. Puzzle of the week. No, we're ignoring those. We don't do puzzles of the week. Let's do a Clash of Code. I don't know why. I might stop doing these, but alright. So, we're doing a coding game. For those of you new to the show, we're doing Rust programming, AI bots, and some practice with Clash of Code. The game we're currently working on right now is a Bomberman clone. We'll get back to that right after this. We've been stuck in the Silver League, but we kind of know what we have to do to get higher than that. There's competition starting this week. I'm still undecided if I'll do it. I don't have a lot of time this time. That's why I don't want to start something just to get nowhere on it, but maybe we'll just try and see. I might just do a bit offline. Otherwise, today I've been fighting with yeah, well, edA-qa, you know, it sounds better to call it a show. Even though it's a stream. But yeah, this is like, we've been doing it for a while now. From episode 28 or something, but I think you're getting good, trying to keep going on that, and I'm probably going to have more time to do more types of things, so I've been doing the Leaf show as well, and yeah, thanks for the shirts. It's summertime, so I have a much better selection of shirts, and I'll try to remember to change them each show, so we have something colorful to look at, and we can identify the shows by it. If you see my avatar on the game, it actually reflects one of my blue shirts, one of my subdued blue shirts, but glad you noticed the shirt. And so yeah, today we're just going to see, in the Bomberman, we're going to do safe area. We're going to be looking for a safe area. And I forgot my water, so as soon as I need a first drink, I'm going to take a pause and go look for it. Right after this match, we can go do that. And no need to let me talk. This game's going to start in about 9 seconds, and as I said, I've misplaced my water, and as I do talk a lot, I'm going to need water. I'm going to have to go find that, but I can't go right now. I have to wait for this to start. And hopefully I don't need to talk too much in this show. We had a visual code started. I'll go to the website where we use our tools as usual on Evening Rust. This is just the public code. There's no actual game code here, except for some of the practice things, or maybe not even that anymore. We've been requested not to put our robots on public repositories just so people can't copy and paste them and just get up to wherever we are. We tend to be in gold, sometimes legend, but there are a few places where we're stuck in silver. This is still technically one of them, Bomberman. And we'll see what happens now. Alright, these clashes are far better for us when there's more people doing it. Last time I think we got number 1, and I can't remember why we got it so fast. I'm not clear why. I think I just got a lucky guess. Now, there's only 5 of us. This makes it really bad, except this mort-ora-y is undecided if they want to play or not. So, here we go. What do we have? Hopefully, I don't know which one. Clash, you're going to have to, so we have to get the test as fast as possible. McChicken sells nuggets pack 6920. Given number of nuggets N, you have to print, if possible, the largest number of packs that McChicken has to sell to complete the order. If that's not possible to some, the largest number of packs has to sell. That seems like there's something wrong in the wording. 5, none. The largest number of packs. And oh my, this is terrible. This one's not easy to solve. Largest number. This is, so you start with the 6s, and then you have to do 20, and then you have to do 9, and then you have the 6. Well, this is unfortunate. These share common denominators, which is going to make it really bad, because if you divide by 6, you might lose the 20, but if you take the 6 out, you might actually not have the 20 there either. So what we can do is we can just do it 3 different ways. Let's do this. Let package 6 equal n mod 6, and let package 9 equal n minus p6 times 6 mod 9. Let p20 equal n minus p9 times 9 mod P20, let R equal. Now this will only come one combination. I'm going to have to do this in 3 different orders, I think. Actually 6, and it'd be the simplest way to do it. R equals N minus P20 times 20 if R is not equal 0. Print line. None. Otherwise, we're going to print the answer. And I'm not going to talk too much about the cat right now because this is a time-based competition. And so what do we have? We have P6 plus... Okay, no, this is divided by. What am I doing? Divided by, and divided by. P6 plus P9 plus P20. Alright, found non-expected 20. So this is an ordering thing, and this is going to get really wacky. I don't know how to do the ordering of this. We have to, like, I could just copy this. There's 6 different orders, but that seems really lame. And, or how else could I do this that's not totally lame? Well, I can make a quick function of this. Function test. We're going to do it in N, which is an I32, and a... Let's do an A is an I32, a B is an I32, and a C is an I32. And it's going to return an I32. And it'll return -1 if it's not okay. And then we can actually just copy this one 6, and that makes it really lame. And I'm just going to keep calling them P6, so we're going to just do divided by A, P6 times A divided by B times B divided by C times C. If R is not equal 0, return -1. Else we're going to return P6 plus. These are not longer P6, P9 plus P20. And what we can do here is we can actually do this. Let mort-ora-y equal test n, comma 6, 9, 20. If I equals -1, then we're going to say I equals test n, comma 9, 6, 20. And at the very end, we're going to do this. If I equals, and I have to do a few more combinations. I just want to see if this works first. And this editor kind of sucks. Print line. None. It doesn't appear to be anybody else who's finished yet either, so that's good. And this is going to be I. And this should work for the first one again. Okay. And what I can do is a stupid. I can just do this different. There's 6 combinations here. 6, 9, 20, and I'm just going to do them the other way. 6, 20, 9, and then there's 9, 6, 20, and 9, 26. And there's one combination I'm missing. Oh no, I did 26, 9, and 29, 6, for lack of a better way to do this. And okay, this is getting weird now. So I'm just dividing the orders to break them down that way. And 6, 9, 26, 29, 6, 29, 26, 29, 9. And so now I'm trying to figure out what are the test cases for this one. Test case 2 is 123, is 20 of them. And so actually the maximum's not going to work. Wow, this is kind of annoying. How do you do this quickly then? Nobody's found a solution. This one's actually kind of hard to do then. It's like a linear equation of it, and that's not good enough. So I thought the combinations would be enough, but it's obviously not. And the largest number of packs of cells. So we can do it a different way. Let's just screw this and do it a different way then. There's the problem right there. It's on the left side. I think I have a different way. I have a brute force approach. And so the highest number we have is let and n divided by 6. And we'll do this, let's do A, let B, oh no, 4. So I'm going to do a loop now. This is the other option for B. And we're just going to try all the options and hope it doesn't take too long. N divided by 9 for C, and 0, n divided by 20. Let max equals 0. I'm going to say if A times 6 plus B times 9 plus C times 20 equals n, then max equals max dot max A plus B plus C. And we have to check them all because it wants the max. If max equals 0, I guess, well, let's just say max equals -1. Otherwise we print I. Let's check this again. I in this scope, where is I? Max. Alright, so this will work. It's kind of awful. Hopefully, it depends how... this is too high the number. So we're going to have one that times out, but we at least have one that conceptually works. And so we need to have something that can actually get fashioned out, because I'm assuming those numbers are really big. This is 5,000. That's just simply too high. What we could do is we could do it in this approach, 29.6, and we'd reduce the numbers in early out on this thing, 29.6, and because then we could do this, let RA equal n minus A times 20, because then we just have to go to RA, and then let RB equal RA minus B times 9. I'm hoping this is just enough to do it. RB divided by 6. No, it's still like... Oh, and it made an error. What can I do now? B is RA. Is n minus A to 20. Is RA minus B times 9. It's made an error. Can I make this any faster? What made that one fail? I don't know which made that one fail. Let's put this back. You know what? These are supposed to be +1. So the other guy probably had one and he timed out on the 1. He probably timed out the same one we timed out on. And ours all actually work now. We don't get the timeout, and I just shrunk the number well enough so our loop isn't quite so extreme, and I'm going to hope that we don't have one that fails in the results here. Oh, come on! So, test case relevancy is very bad. Failed actual test, passed control tests. That makes them bad, that's why I qualify it. The statement is actually not clear. It's not clear what they mean by max, and that made me do the loop. And the difficulty here, this is too hard for this game. For something that has to be fast, this is too hard, because I tried 2 solutions and mine doesn't go fast enough, and this is just really awful. And almost won the Telemaster of Nuggets. So yeah, well. My code actually worked. I mean, so the issue here was that I'm assuming I timed out on one, and we passed all the tests, but one of theirs must have been slightly higher. And obviously there's going to be some sort of algorithmic solution here better than this. I just tried all the combinations, but to be honest, I don't know what the other solution would be, because it's a random combination of these items. And I took the biggest ones out first, and so I don't know what... I won't think about it too much, but clearly the other people are having problems with it, so That one's not a good one for such a clash, though. It's just not. This one will be converted better to a practice thing and have different types of inputs. So you have different inputs that you would vary it on. And I'm still trying to think of what... It's really just a permutation, and there's really... I don't know. I don't know if there's a way to optimize it fast enough. Alright, whatever. Let's move on. We'll see where we are. We're at least number 2. We're probably number 2. I'm guessing these guys, if they're looking for a solution. And the only reason I pressed submit is because we passed all the tests and we got cheated on the final thing. Alright, let's go over to Hypersonic. But hello Galva and hello, what was the name again? Inigo. Inigo Montaña. We're going to join this. So this is Bomberman, and just a sec, I'm going to go grab my water. I think it's just outside my door. My mouth's getting dry. So I have my water now. And so we're at rank 68. This is kind of where we left it off. This is in the Silver League. And the main thing we do is we die too often still. So we can take a look at some of the games where we lost. Last battles. Let's look at one where we lost. And we're orange here. Let's see if we die or what else happens to us. Our bot, I mean, he looks to do intelligent things, but I think it's just the dying is the problem. And it might be the chain reactions are one issue. And so what we're going to do today is we're going to find an algorithm that finds a better safety algorithm. And it has to be fast. So one of the issues we have now is that if we even didn't walk to safety is that our code's exceptionally slow. And I can't do many iterations. So we have a recursive search here, but we just can't test it very much. We can't do very far down. If I could do a few more steps down, we'd probably win. But I want to try and do a safety heuristic before we try to improve the speed. Because I think the safety heuristic, I'm going to see how I lose here first of all. That'll help us determine what we actually have to do. Yeah, and that was one we just... The chain reaction is what we missed there. And so I didn't walk out of the way. I clearly could have walked out of the way, and that was a chain reaction that I missed. So let's look at another one. Let's see now. Let's put the speed it up a bit. And actually, let's just go right to the end here. Yeah, and chain reaction again. It's a chain reaction there that I lost. And skip over here to the part where we lose. Whoa, what happened there? Oh, I'm a different color now. I'm 4. Keep them in colors. So, where the purple guy, what does the purple guy do? Oh, I just got stuck in an unfortunate situation. Is there a way I could have prevented that? No. So this one is one that we legitimately lost. I ran away and he trapped me, and there was nothing I could do. So I'm not worried about this situation right now. That one's okay. Let's find another one where we lose. And we're orange. And we die at the end. Which we look to be in a safe position, so I wonder how we die. Alright, chain reaction again. Alright, let's pick another one. So mostly it's been chain reactions so far. And again, it looks like chain reaction. I assumed I'm safe, but my bomb took me off. So we're now red in this one. If it's another chain reaction, it's very clear what we have to do. Alright, let's look at that one clearly. Yeah, so what's happening here is, to explain this chain reaction, I can't make this bigger, unfortunately. Here, I can put it to the ID and we can see it's there. And we finished 2 in the clash, so the other guy just gave up as well, or he suffered the same problem and complained about the text. Come on, submit this. So let's hop over to where we die. This isn't the same one. This isn't the same way we died on the other screen. That kind of sucks. I copied it to IDE and we don't get the same parameters. But let's see where we died. We're red over there. So we have red. Red's up somewhere at the top right here. And I put one, I walk, and he puts one. And so what happens, well, I get trapped here, but I don't see the chain reaction here anyways. So let's go work on the move to get us into a safe place. And I think that's the key one because it looks like the way we're losing the most. The fact this guy drops lots of bombs is another story, and we don't track that yet. Now, still we have this issue with RLS. RLS is the plugin for Visual Code that lets us see players or errors. And it works great once, but the moment we save something, it breaks and stops working, and it's really kind of annoying. It's really unfortunate, but there's not much I can actually do about it. Alright, so what do I want to do? Where am I? That's in strategy. We have strategy tests, and we have strategy here. And get my best turn. And I can't see it in my glasses, so it's the first thing I have to do is clean them. It's a day of things. So on get my best turn, we try to find the one that's best for me. We skip the invalid ones. And what else do we do? Is valid move. And we say can walk safely away. Can walk safely away. And there's something called likely die. And if there's any state where we likely die, we don't evaluate that. So here's the issue now is that if I improve this one, if I do what I want to do is I want to search for a safe space. This can make our algorithm even slower, but I don't think there's much we could do about that. I absolutely have to find the safe space, and we absolutely need to know about it. And we might take this out of the iteration, because it's really only the top level move we have to care about. The iteration can explore through whatever the hell it wants, and only the top level move do we have to say, well, wherever I go, am I safe? If not, just don't do that one. And that might be an easier option for speed-wise. And so let's look at likely die. Likely die, we'll leave it this way first. And likely die, we find player. If I'm already dead, it returns true. If there's an entity within bomb range, and that's very clear, and can walk away safely. This is the one where we're going to try to, where we have to try and fix. Can walk away safely, there is now very simplified. It considers one bomb, no chain reactions, nothing like that. It considers all the bombs independently, and that's where we're dying in a lot of them right now. And it's also not enough to go. We might have to go multiple steps. So what I want to do is I want to put an A star on this here now. This likely die I'm going to change to be given a board state in my current position. I want to find, and I'm trying to think, I had this worked out in my head, it's very difficult. Where do I actually have to walk for safety? And I wonder if there's an easy program that I can show this in so we can understand what's going on here. And let's open up Calc maybe. Can I easily color these boxes? Can I easily make them bigger? Row height. Let's make them 2 in size. There we go. So we have boxes. Maybe we can make them colorful. So we're going to make one of them, we're going to make it a, let's say, a background color. We're going to make this a bomb. So make these ones bombs. So there's a bomb here, and it has a number, like, it's going to detonate in 4. And we'll make the font size like 36. Can we center all the fonts? We can't. Alright, so this is our new super-powered Bomberman thing. And we're going to put a few walls on. Let's just ignore the walls first of all. And let's say I'm here. So I'm here. And this bomb goes off in 4. What we want to know is where is my steps to safety and how far can I get to it. And so all these empty spaces are safe spaces. So we're safe right here and right here. And right here we're simply not safe. So we can't walk that way. It's not safe. But what you might have is here's a spot of 2. Sorry, now let's change this. This is 0, so this is safe. And this is also safe, which means this one's 1 away from safety. And if these ones are 0 and this one is 0, this one's also 1 away from safety. Which means the current one we're on is also */1, but that should be obvious. So what we're trying to do is we're going to try and do the A* for that. So now let's put a wall in over here. Let's put a wall and a wall. And pretend we can't walk through the bomb right now. Pretend we're over here. And so we're star right here. And there's empty spaces over here. There's a wall and a wall and a wall here as well. Now, how far away am I from safety? Ignore this number on the bomb for a second. Well, where's our first safety? Well, we initialized the grid with 0. These are the safe spots. And we'll get to how we calculate the safe spots in a second. So how far away am I? If I do an A* or I do a reverse flood fill, that's where I'm trying to decide the algorithm is that, well, here's a 1, and this is a 2, and this is a 3. And this is the grid we need to come up. This is what we need to come up with is based on the current state. We need to come up with this grid form. And let's just make these things gray so we can see them. And what we have to do is we have to initialize the board. Is that essentially what we could do? Let's pretend there's another bomb here now, though. Let's put another bomb, and let's check out the chain reaction one. So let's clear this one first of all. No fill. And let's put a bomb right here. And we can say this one's 7. This is the one that takes 7. This is how many steps it's going to do. And let's put another bomb right here. And this one takes 3. Okay. Now, it doesn't change our safety motions. This doesn't change our safety. We have... This one's now 4 away, assuming we can't walk through a bomb, which we can't. And we're right here. And we don't have to evaluate things where we're not around. But what we have in the current game is that we have to recognize that this 7 is actually not a 7. This 7 is effectively a 3. And, well, that's kind of annoying. Let's change the font size a little bit. Who chose this really big font size? Come on, font size. You know, interpret that as a date. Sometimes I hate this program. I use it for like lots of stuff, and it has stupid detection. I mean, whoever uses LibreOffice is kind of annoying. It has stupid detection. It detects anything you want as a date. So this has an effective number of 3, and that's because it could be hit by this one down here. And I'm not clear on how we set this up in the map. And so we have a couple options here. So we have 2 things here. We have to figure out these numbers first. But we could basically start and say, with all the bombs in the map, just walk from each bomb to the other ones and figure out the chain reactions. And the chain reaction then would become, well, this 3 hits this one, so it has a 3 value. Reduce that value because it's going to blow up in 3. That's its effective score. And then for the distance to safety, if we initialize the board to... Well, we could have a second shadow board. I'm wondering about that. Do we want to have a board which says, well, everything in range of this one is it's going to be a bomb in 3. So it's going to be like a x3, x3, x3. And so this would be like the bomb size going off. And then it would have the chain reaction here. And what would happen here is that we'd actually have the same values here, because this one goes off in 3. We'd have 4. What the hell do you put a new line in here? And this would be x3. And this would be x3. Ah, come on. And this would also be x3. If the bomb went further, you'd have further. Let's say this bomb went further, so you'd also have x3 here as well. And let me reduce the font one more step so we can get this fit in. So what I'm saying is that there's 2 things on the board. Is that this spot is not safe in 3 moves. And it has 2 scores. So in the X, and what it basically means is that if the A star code, so if the number here is 2 or 1 or 3, it means we're still all right to save here because we have enough turns to get away. But if we have this 4 over here, 4 turns to get away, says, well, no, that's too long to actually get away. And so that's basically our elimination. And basically, if there's ever a consideration that puts us in like this position, well, you just discard that part of the tree because that's not safe. Don't consider this move. This one here, I have to see, this one might not be safe as well. We might have to say it's less than, but this is a simple equals or greater than check. It's an equality check. And this will make us prefer going away. So this one, 2 here, it only has one option. I could sit here, or I could move away and see what happens. The question is, how do I generate this grid? How do I generate this grid in an efficient way? Well, we have 2 grids. Let's just make 2 grids. We have the one with the bomb itself, where all the bombs are going to be, and this is a number. This is a number between 0 and whatever, and how many turns the bomb appears there. And then we have a safety grid, which says how many spaces to safety do I actually have. And that can be an A star. So we can start right here. If we're starting right here, we can use the 1 grid and we can start searching for it. Searching for it in each case, for each of the ones here, how far we go down, how far am I to safety, but I actually need to know which direction to go as well. This is why it's not quite an A star, is that I really want to know for all the spots around me, how far do I have to go to safety. But I could, and yeah. So that's the situation we have now. How can I actually do this efficiently? Let's create a bomb map first. Let's create a bomb map, and we can break this program down. Let's create a bomb map. That's the very straightforward one. And we can do this one right here. We can do public function, create bomb map. And it has a state. We don't need to modify the state. And we're going to need to produce something. We'll just let it produce a new matrix for now, and a new matrix is of type I32. Okay, and yeah, this is so annoying to do. I mean, because of the fact that the bomb's going to have lower values, I'm trying to think that creating the bomb map's actually quite hard to do, but I guess we just have to start doing it. And the chain reactions are the hard part. It's not the simple bomb to do, it's the chain reactions we wanted to create. So let's first create a new grid. Let mut grid equal matrix new state dot. Do I have a size in here? Size.x, state.size.y. Grid.fill with 0. There's no bombs. It's we have a safe grid. Maybe 0 is not a good thing because in how many moves? Let's start with a -1. Let's say -1. There's no bomb in there, and 0 means there is an explosion on there right now. And let's do the simple ones first without we're just ignoring chain reactions. Let's just go through all of the entities. And fill them out. Standard is not equal lambda type bomb. And we can continue. Okay, then we can simply return the grid at the end. We can have the grid. And we'll make a test for this one because we want to have tests. And this is where our RLS plugin already started failing. It's just really unfortunate. I don't know why. It was really helpful to have. I really miss it. I really miss it. Okay, so if we have a bomb, then for each bomb we can go in each direction. We have offsets here somewhere. Where are the offsets? Offsets. Offsets are right down here. Okay. And we'll just do this really kind of inefficiently right now at first, and just to simplify it a little bit. I'm trying to think if we should mark a bomb somewhere, somehow, other way. How can we mark a bomb? Chain reactions are just a bitch. Let's just ignore it first. Let's just ignore chain reactions first of all. So the entity has a bomb, and for I in 0 dot dot entity dot, and do you know what the param is? 1? Parameter 1 is how many... Wait, no. Parameter 2 is how far the bomb goes off. I don't know if you can put aliases in Rust. I don't know if any language allows it. I'd really like to call this parameter 2 something else. Maybe I can change that. Does entity have a... Are there like field getters? Does Rust have getters? Get accessors. Let's find out. Rust get accessor. Work in progress. Well, that doesn't sound good. So if anybody knows how to do accessor, it would be helpful. Otherwise, I'm going to create just a simple public function here. Public function bomb range. And I'm going to make it a function. It's going to return an I32. And it's simply going to return, when it has to take an and self, it's going to take a self dot parameter 2. Bomb time. And self is an I32. Just because I'm getting confused by my code where these things are used. So bomb range, self to bomb time. For example, if we look up wherever parameter 1 is, this is clearly a what? Bomb time or bomb range? Well, this one looks like bomb time. Yeah, this is bomb time. And so this makes this algorithm clear. Bomb range. Okay, then I don't have to worry about it. And so now I want to do entity and bomb range. Probably don't need those. The pop-up stuff in Visual Code, we've tried to turn this off before, or I set the timeout to 2 seconds, so I have no idea why it keeps popping up on us like immediately. And it's one of the reasons I wouldn't use this editor for anything other than the show, is because on the show I can deal with it a little bit, but on my own coding, when I have these things pop up all the time, they just get in the way. And I don't really mind pop-ups, but what I think they screw up is that it shouldn't interfere with my arrow keys. Like when I'm moving around with the arrow keys, regardless of what I type, the arrow keys and typing should not be interfered with the pop-ups. I should have to use a special key to get into the pop-up, and then it wouldn't be a problem. But because my arrow keys, you can't simply scroll through the code and randomly type, it gets broken along the way. And so for off in, this is going to be offsets. Offsets. Let NP equal entity position plus I times offsets. So this is a new position. Now we're going to check the current value of the board. Let current equal grid.get np. Actually, what is it? Get def. There should be a get def, I think. Get def is valid, otherwise return p. I don't know what the default is yet. What is the default going to be? We're going to say less than, so if we have a ridiculously high value, no, we'll just say -1. It's never going to be -1, actually. If entity.bomb time is less than, and let's just get this out right here. So bomb time, in case there's, because we're in debug mode. If time is less than current, then we set grid.set np time. And we continue, and it just goes through all the bombs and sets the range, so we create a bomb map. So let's go over to strategy test and actually test this thing. F, and what do we have? We're going to make the function public create bomb map. Create. And we forgot to mark this one as test. That might fail on us. Wow, that might have failed on us before. So we create bomb map. Let put state equals state new I point 2. Let's do at. Let's just create a 10, 10 map. We're not going to test all of it, and we don't need to initialize it, I think. We're just going to add a few bombs. And we actually have to check for walls still, so yeah, you know, we're going to have to actually create stuff. It's kind of a pain. State.parse. One, 2, 3, 4, 5, 6, 7, 8, 9, 10. See, this is what I mean. I just press a key and it takes that stupid pop-up. 4, 5, 6, 7, 8, 9, 10. And we just close this off. So we have a state parse function. That makes it very simple. And now we're going to add an entity to it. We're going to make a bomb on here. State.entity, add bomb. We're going to add the bomb. Let's add it at 1, 1, and that'll test the coordinate things. And this is the, what do we say, the time and range? Or what was that again? Kind of annoying. Time then range. So 2, and then it has a range of 3. And we're just going to do a state.edump on this, state edump, and see what comes out of this. Clean and cargo test create bomb map. Clear, I meant. Alright, what do we have? No implementation of I32 times point, which is quite possible. So we have multiplication by a scalar. Can we do the opposite as well? Can I do multiply I.2 for I32? We're going to find out. Type output equals I.2. And I'll quickly copy this because it's basically the same thing. Self, but this is a point, and that's an I.2. Well, it's not quite the same thing. Self times point.x, self times point.y. Let's see if we have that now. Alright, because this is actually I.32. I.2, sorry, never mind. Alright, so that works. So we can do that way as well. And we have lots of warnings, that's okay. Strategy G44. Oh, it's in tests actually. Get my best turn takes 2 moves. Well, that's weird. We didn't run these ones last turn. Get best turn and mutable strategy. Alright, because this one doesn't actually create strategies yet. Well, screw it. Let's just comment this one out for now. I don't care about that. I should probably save it. That usually helps. Okay. Now, it failed, which is, you know, probably bad. Where did it fail? Where is it in our code? Create bomb map in edump. Edump is... Oh yeah, edump. I forgot about that. Edump actually fails if you don't have a player. So you have to set a player, I think. That's the same mistake I made before. Make sure you always have a player. And let's just stick them off at 0,0 for now. And that's just for the dumping thing, so... I should probably just check that it doesn't do that. Find player still failing, which is really annoying. And entity, because it has to be done. Well, let's just fix that damn thing edump so it can dump without having a player. Edump. State edump. Edump. Where's find player? Let's make a second one called if find player. If find player is an optional entity type. Now, do anybody know how you can do a deep clone? I think we had this once before. So if I have an option of a reference to an entity and it's none, I want to return none, but otherwise I want to return a deep clone. So like if let someone entity equals this, then we return some entity.clone, else, and this has bad indenting in Visual Code, else we return none. I'm assuming this pattern exists. And we do an if find player now. If us.isSum is sum Alright, now I want to see the output. And we still don't know how to get this thing to only run the one test. It's like, it runs everything here. Even though you have a match, a create bomb map, it just decides to run a whole bunch of them. But if you put create test here, it can't do that, but it can run a specific test. I don't know what it is. It recompiles every time as well, so I just don't know what that is as well. So we still have some issues here. We don't understand how it works. Create bomb, it actually interferes with it. It kind of creates problems that we don't have the syntax we want for cargo test. I want to run just one test in a specific thing, and I don't know what the syntax is. If anybody could tell me what that is, I really want that. Because you can see it runs tests. It scans through every directory looking for it, and I don't want that output. I just want the one test to be run and hide all the other outputs. Okay, and now we have to go to... Oh, I took that thing down again. Evening Rust. Oh, it's supposed to be there, but let's check it out. I'm looking for the syntax to output the standard output. If that made any sense. So we have these two things. You can run a test by given name, but this then scans everything. Or you can then run -test and it scans, I don't know, it's just weird. Maybe if I just do -tests, And just do both of them, dash dash test, and then dash dash and dash dash no capture. Alright, so create bomb map didn't actually work, as you can tell. This bomb never went off. Oh, no. I printed out the wrong thing. We don't even want to print out... We don't want to print out the state. We want to print out the grid. We don't care about that. We want that the grid equal create strategy, create bomb map for the state. Okay, do we have anything to print out the matrix? No. We can do one here though. Not wait function. Print matrix T of mat and matrix T. No, don't have that. For y and 0 dot dot mat dot pop-up would be helpful here, but we don't have it. Mat dot height. For x and 0 0 dot mat dot width. Print line. And we're just going to do it a really cheap way for right now. We're just going to assume this works. Mat dot get xy mat x comma y. Print matrix. Great. Not found in this scope. I guess we import that. Use Hypersonic. Matrix. Start. I think. I probably meant print line with an exclamation. Yes, I did. State. It wants an AND state. And what else do we have? Grid. It also wants an AND grid. Come on. It's private. Why is the matrix height private? Can you make these things read-only? I thought it's a read-only. I thought there was a way. I forgot what it was. Rust read-only property or read-only field. I don't know what they call them. Rust. These don't have to do with Rust. DuckDuckGo, you're doing a terrible job here of finding stuff for Rust. I'm positive we had read-onlys before, but I don't remember what it is. So I'm just going to play wild here and make them read-write. Get XY. Well, it is right, though. It's... Now what the hell is it complaining about? Well, it's an I-32, so it should have... What the hell does this mean? Standard marker copy. Don't know. Don't know what that means. See, he has a simple... Not helpful. What does this thing do? Yeah, this is odd. Why can't it print that thing? What if I just do clone on this? I don't know. Well, screw the template then. So I don't know what we have to do with this to make T work. This seems really weird that it didn't. I don't understand the issue there. Alright, so our bomb obviously didn't work. Because we had a bomb on there, we create the bomb map, and we don't get the correct grid. So it's a good thing we tested this. And we're going to put a space in between all of these, just so we know. I'd like to put a fixed width. Anybody know how to do that? Can I print it out to exactly 2 wide? Whatever. We'll worry about the formatting later. The key thing is create bomb map doesn't work. Create bomb map. We add an entity called a bomb. We add a bomb at 1, 1. So it should have actually found it. Create bomb map. Grid.fill -1. If... Oh yeah, because we're -1 for that, and... Because -1 means it's safe. That should almost be an infinity instead. Well, we could just start with a really high number, saying how many turns does it take until that gets bombed. But we don't really know. It's hard to say. I mean, it would simplify if we just had a number there. Because putting the -1 is going to make it more difficult for us later. Let's do -2. Or current equals -1. I don't know if it's the best approach. Alright, so it actually fills out. I don't have a way to do the formatting here. There's a format, Rust. Okay, Rust print format fixed width. Cool, that'll work. Oh, I don't know. Let's try it. Let's see if that prints something. So it wants parameter 0 less than 3. Well, probably like this to get right aligned. I'm just guessing randomly that I don't know what else that symbol would mean. Alright, so we can actually see the grid there. We have the bomb that created it. And it says a span of 3. So let's add a second bomb to see if this is actually working. We're going to make this bomb go off in 5. And it has a range of 4. And we'll put it all the way over at 9, 9. And see what happens here when we run this thing. So 5, 5, 5. It says this is how long, this is when this position becomes unsafe, and in 5. And this is where I think it makes sense that if the other values here are actually infinity, not -1, they're just infinity, saying this value is safe forever, the bomb map. And I'd actually like to do that. But there is no infinity. There's an I32 max. Max. And we'll just say 0 here, because it can never be less than 0. But it's going to screw up our format, I think. Do I have a max somewhere? Standard I-32 max. This is another one that confuses me, that there's an I-32 and a standard I-32, and they're not the same thing. I don't know. It's weird. Yeah. So let's fix our printer as well. Match. I should just do this. Can I do ranges on max? Let's do without. I don't know if I can do a range. If C is greater than, let's say, 99, else. And this just becomes 1, 2, 3. Let's see if this prints out something we can debug with. Alright, so that looks like a decent bomb map. So this bomb map, the one thing we're missing now are chain reactions. So what I want to do is say right here, let's put a bomb right there as well. And that's at 3, 1. 3, 1. And we'll let this one also go at 5. And it has a range of, let's just say, a range of 3 again. Now you can see the issue here is that it has these 5s, but the thing is that when this 2 blew it up, the chain reaction meant that all of this should have been 2 as well. And this is critical that we get this right, because this is why we're dying in the game right now. So we have to do these chain reactions somehow. And how can we actually do this? Well, I can create a copy of all the entities. Let's do that. And then we can sort them. Alright, well, let's say let bombs equal state.entities.iter.filter entity type bomb. And we're going to sort by entity, and we're going to sort by the bomb type, entity dot the range, bomb time. So these ones go off first. This is going to be a mutt of bombs. Now I'm hoping this copies it somehow. I don't want an iter mutt, I want like a collect. I want to collect on this then. I want to do a collect. And this should become a vector of entity. And I'll explain why I'm doing this. So what I want to do is I actually want to go by index here now. I don't want to do an iteration. I want to do for I in 0 dot dot bombs dot len. And get rid of the filter. Okay, now we have to walk through here and actually say yeah. Okay, so we can cheat. So we say if entity bomb time, but if there's something already in the grid there, we know that the bomb has already gone off. So we're going to say let CB current. Well, let's just do the current time equal grid dot get. We know it has to be valid, and this is the let bomb equal bombs I. And this is the bomb dot position. And this can actually be this, the minimum of this. Right, so what we're saying is that the time this bomb goes off is either the bomb's time, or if something's already blown it off, that time there as well. And then it goes and set this off. And the reason we did the sorting is to do all the smallest explosions first. so that we take it into account that the lowest explosions do the chain reactions right away. I'm sure I screwed something up here. Entity not found. Oh, that's right. Just do entities so it's clearer, because that's what we had before. Okay, state.entities. Why is it not state.entities? Oh, that's what it is. Private, so bombs.length. Yeah, so filter by entity. Let's just do it this way. And what equals bomb. Alright, so what is sorting by? Rust sorting, rust sort, rust sort, rust sort. Sort, rank by, sort key. Size sort by key. Well, sort by would be correct. Do I have to collect this thing first? Ah, that's right. This I don't like Rust for this. The inability for to use call things like collect. How do I collect the clones? Rust, collect clones. Rust, collect clones, or collect copy. Anybody know how to do that? What is clone from slice? No, I need to filter. How do I... collect. Well, I can probably do something stupid like this. Map end to end. The type of this value must be known. Well, how the hell can it not be known? As a whole, I'm actually kind of disappointed with Rust's implied type system or inferred type system. I thought it saved me a lot of type headaches, but it actually ends up creating more type headaches than it solves. You end up having to put the type in a lot of places, and you get these weird type errors. Like the type of this value must be known, when it's clearly it is known, it just, for whatever reason, the inference engine is confused as to what the hell it should be. Like, how can it knows it's an entity and knows the type of bomb time. So either this error is totally messed up, or I don't know. You do know the time. Entity right here, sort by. It's a type of vec entity, and you have a type of vec. I want to sort an array. Now this is a comparison function. Well, I can use sort by key. Sort by key, maybe. Okay, so that was a case of just having a horrible error message. But now you actually see we have the 2's here. This is what we wanted. So we have this chain reaction. We definitely have the chain reaction there. And let's add another one to see that we have a further chain reaction. And I'm not actually going to put the certs in here. We're just going to look at this. Bomb type 6. I'm going to put it way down at 4. That's also 3. 3, 3, which is down here, the spot right here. 3, 3, I think. And we can give this one a range of, let's give it a range of 1 just to make sure that works. And it doesn't matter what its timeout is. It'll just gonna make a little tiny difference there. And it didn't. That's a good thing to check, because the range of 1... No, the range of 1 makes sense, because it has to have at least a range of 2, because we count the item itself. We count the square it's on, and that's where the game does it. So now you actually see in 2 times... So this, we have the chain reaction now. Now we have a proper grid, except we have to put some walls on here now. So the first wall we want to put at is on 3, 2. We want to put a wall there. So we shouldn't see this thing here anymore. We shouldn't see that. And we're also going to put a wall here to block that second chain reaction. And so that should block the chain reactions, and we shouldn't see explosions there. And what do we have now is... But we have to clean this up. And this is where we have to check the state. And we do something like this. Oh, and this is really annoying because we have to check each direction on its own then. So we're going to have to change the ordering of this. So we're going to have to go through the offsets. And then through the bomb range, because you have to break out of this. And we want to say test the grid state.grid.get np as a default type of wall. If it's not empty, we break. Except if it's a bomb. And grid cell does not equal cell type bomb. So bombs have to go through and set the grid type as well, but now if it's a grid, now it's really a grid cell equals cell type bomb, then we can break as well. It's just a matter of where we break before or after. Then we have a wall, and that should be enough to spot the things. Oh, well, no breaks everywhere. Oh, well, we shouldn't be checking ourselves, because we assume we're a bomb. Duh. I is greater than 0, and... Alright, so we blocked it off here, and we get these 9s here. And this is where the logic of the game is kind of weird, is that the bomb does block the bomb, but it sets off a chain reaction. Maybe I should check that. Maybe it doesn't. Can anybody verify? Does the bomb actually block the bomb? I think it does. Each bomb is range. Let's say enter a wall, box, item, or other bomb. Destroy from the comments. Okay, so they stop at virtually anything that's not empty. They also destroy the items, but it causes them to stop. And that's the key thing. They cause them to stop and not to propagate. Caesar's propagated, deploys it, so that works. I think this is working well here. We have that you can't see the walls now, but I think the test basically shows that this function is now correct. We have a correct function that does whatever it's called. Create bomb map. So now what we need to do is give it a bomb map. And a state. We want to find a way out of this thing. Now, do we do this with an A star or just a simple recursive search? Because we don't have many moves we can go consider forward. Distance to safety, and I'm trying to think of how we do this now. Given a bomb map, where is our path to safety? These are hard to test because we need a visual testing for this. Let's check back at my grid. What did I have for that? So I have my bomb map. This is all these X3s. I have all the places where the bombs are going to be. Now I have to decide where's my path to safety. From where I am right now, where's the best path to safety from there? And that sounds kind of like an A star, but I need to backtrack the numbers. This is what's really weird, is that to get this 3 here, and to get the 2 here and the 1 here, I have to backtrack from the safe spots towards the A star. So we're going to have to inverse that. We're going to have to inverse the meaning. No, how can we do that? I've not done one of these. I have to inverse the A star. I have to figure out how far is it to safety in all directions. From any given square, this is dynamic programming, how far is it to safety from that square, and then we add 1 to here. And not get too ridiculously recursive. Oh man, how do I do that? Huh. This is kind of a weird flood filling one. Is it dynamic programming or actually flood filling? The actual flood filling here would be if I start from all the zeros. I start from all the zeros on the map. And I trace towards the player. I get from all the way and I trace towards the player. And I add the scores. That would work, but that's going to be exceptionally slow. And I really want to do the reverse. I want to go from the player. I want to find the path to safety. And I don't just want to know what is the correct path to safety. I want to know how long it takes me to get there, preferably for each step along the way. Each step along the way, where is the path to safety? But perhaps I just have to do each one. Perhaps I just have to do... And the reason I don't want to just say, well, let's check both sides, is because I know both of them are going to end up calculating the exact same A stars to where that path is. So it would be just a little bit easier to figure out, well, where... Let's just calculate them all at once. But how do I do that? Does anybody know how to do that? So what is the is it recursive? Is it a recursive algorithm? And well, I could persist the A star. That actually makes more sense. That's an option. What I can do, I'm thinking out loud here, is I start here, I start right here, and I say calculate the A star path to safety, and I'm just going to count the number of steps, 1, 2, and it's going to be 2. It says, okay, it's 2. And I can do that one recursively so that it actually asks, well, what's the steps on this one, and what's the steps on this one, and we keep a mark up of it, and we mark them how far away it is. And then for the next iteration, we can go and start at the next one. But then we have these open nodes that we don't know about, and we can just discard them. If the node has an open node, we can just discard it. Yeah. And is it worthwhile doing A star, or do we just do a flood fill recursive here? It's like I know all the options we're trying to, and I'm unfortunately forward thinking to optimization in the end. I need to know, and this has to be super fast as well, because we're going to call it like a million times, and maybe I should just ignore that first of all. It's very clear I want to know it from the clearance position, actually from any position on the board, let's generalize it, from any position on the board, how far is it to safety from this position, and that would be a flood fill, but that's a lot of open nodes. But maybe that's just the best option. It's the cleanest one. But I'm trying to avoid it. So what I'm saying is that instead of just working from the players, we just want to say, let's just fill the whole board and take all the zeros, mark them as open nodes, and then just fill in the steps to everywhere, how far it is. So we just start filling, oh, it's 0, we have all these open nodes. Oh, and so this one would then be, this is going to be a 1, and this is going to be a 1 as well. And that's one way of doing it. And it's not exceptionally slow. It is, but it is a lot slower than I can somehow figure out for the player. But the flood fill approach could actually be faster than the A star approach, because the A star approach, if I recurse from the player and there's a long pathway, it might actually fail. But at the same time, the player doesn't have to walk that far. If he isn't out of the bomb range within that time, then you can stop searching as well. And so what I'm trying to think is, what's the best way to do this? If I needed to find the whole grid, I would do a flood fill. If I need to find a spot, part of it, I can do that. And I know the flood fill is going to be a linear operation. And that's what's appealing about, is that if I start with all the zeros and add them to a list, ignoring the fact that that might not be linear, and then I just keep checking all the open nodes, I can flood fill the distance through the whole grid in a linear operation, and that does exactly what I want. Whereas with the player one, there's a good chance it's not linear, but the number of steps might actually be lower if the safe spot is close by, or we just don't have enough time to walk. And I'm just trying to think of where... Shit, how do I want to do this? Let's just... Well, let's just do the... I don't know, let's just do the flood filling approach. Does flood filling make sense? And compare how much it grids. And there's a lot of bombs, and there's a lot of bombs. It might be better to start from the bomb squares than the empty squares. But then we have to push the open squares. Oh man, the open stuff is just... This is very costly. Whichever way I think about it, this is going to be very costly to figure out what the open space actually is. I have the bomb map. And maybe I'm trying to over-optimize, because right now we have a can walk away, and we only check that for a single position. I'm not checking multiple positions. I'm assuming I have to, but that might not be enough. And this is going to be another breadth first search. This is going to be a breadth first search then to walk away safely. The first place that I can find that lets me walk away. Because usually it's only going to be like a 3 or 4 step walk. So there's too many algorithms here I want. It's the walk away safely now. We create the bombs. We create the bomb map, and from the bomb map, how do we tell which way the person has to walk away if we're on a bomb? And this is the classic A*, walk to safety. And it wants to return the fastest way there, so yeah. Anybody remember how to do A* to exclude the places we've already been? I know the theory of A*, but now I'm just trying to think of, well, it's not even A* because I don't have a prediction of where I have to go to. It's the flood fill, and I have to mark them as considered. That's right. I know how to do it. I know how to do it. Okay, I know how to do it. The first thing we're going to do is we're going to create the generic algorithm. It says, given a map, how far does it take to walk to everywhere on the map? And from there, we're going to early out on that. But let's do that one first. Let's do a walking map first. Public function. Walk distance. And we're going to do state, and it's going to be an AND state. And position is going to be an I.2. So I want to know from everywhere on the board, how far is it to get to all the other open spaces? What's the quickest way I can get there? And this just lets me think about it, because it's basically going to be an optimized version of this. We're looking for the first one. I'm going to put a filter on it then. And this is going to return a matrix of I32, I think. Yeah, that's what the other one returned, a matrix of I32. And it's going to look much the same. We're going to create a grid. And it's going to start to be initialized with infinite. And we're going to use a queue on this thing. We're going to take the current player's current position. We're going to have an open queue. And I created this in the Tron game, so let me go take a look to see if I actually have this still. We have a flood fill here stuck in here somewhere. Somewhere in here we have it. Let's go to location, block board, score log count scores. Here it is, this heap queue here. I'm just going to copy this over, and we'll work with the structure. This is some of the older Rust I did a little while ago, so it might not be the most ideal thing. And these are these algorithms, these flood filling algorithms, and I've been meaning to do a series of articles directly based on them, is that they're really annoying because as much as you try, it's actually very hard to make a generic, efficient algorithm that can apply the same formula, because they're usually such little tweaks always specified, and it's just annoying. Okay. So location, we have an I.2. Distance, I don't think we need we don't need a player, because we were calculating a Voronoi diagram in the other one, and we're just going to calculate the player in this one, so it's a little bit simpler. And we don't have heads, we just have open, so we're just going to push back one, open, push back, and it has open, and the location is position, and the distance is 0. This is how far it takes to get there. Distance is 0. So like I say, Tron was creating a Voronoi diagram, and this one is just creating just for the one player. And Voronoi diagrams, if you know, they're for a whole bunch of players, how quickly they can get to each position, and it marks the board. And we're going to pop off the front. Current distance is is going to have, let's call this one dist board. Distance board, so it's clear, so we keep calling it distance board. Current distance board get op lock. If the distance is greater than what's already there, then we continue. That's how this kills iteration. Otherwise, we take the distance board and we set op.lock as op.distance. So we can ignore, oh, that was right down there. We don't have the player, so let's drop the player. Let's simplify it. Next distance equals op distance 1. Now we need all ders. Yeah, I should have copied that over as well. Oh, we have offsets. Offsets. And offsets. And offsets. This is slightly different. NP equals op.lock plus offset. The other one is using a step-based system. The board is free. We don't even have to consider this one now. We have this get thing. We can do a get def here and then just do standard I32 min. Because this will mean it's never... It means it's always greater than that. So we don't even have to check to see if the board is free. Although we should check for walls. And checking for walls would actually help. The reason it might help checking for walls and other items is because it trims down the list of what we're checking. But I think we had a free somewhere. Is valid move. Yeah, we have an is valid move, and it's you can either walk into an item or empty. Is valid move. If not, and so we can get rid of this get because they're all going to be valid moves. Is valid move, and this will be the state and the new position. If it's not a valid move, we just don't consider it. Otherwise, we take the next op, as we take the next position, the distance is next distance, and whatever else was an op. There's nothing in op, so let's drop that. That was very simple. Now, this is our vector deck. This is a bit of an optimization, is that if we don't have anything in there, we're going to push it to the back. Or if the next distance... Or if it has the same distance as the front, we push it to the front. It's not clear how much of this we actually need, because we're always going to consider the lower distances first. Basically what we're doing is we always take the first distances and then add them all to the back. And since we're always doing by one, I have a very big feeling we can just push back here. Because this is more of a general thing, because we're always considering the first one. There's no possibility for some other ordering to come in, so we can literally, I think, simplify this just to this. Put these all in the back, and that's the order they're going to be processed in. And this results in a dist board. Okay. So let's go back to our tests, and we have this in a few places. We have a few weird grids here, and let's just do a second one first. We're just going to output it test function walk distance. And we don't need these guys anymore, I think. Okay, I should just get rid of them. We can create a slightly smaller grid now. Let's make it 5 by 4. 1, 2, 3, 4, 5. We'll keep the first one open. Ugh, stupid crap. And I'll create like one little box in here, so you actually have like a little spaces where you can't walk to. And we'll actually block off the bottom right corner so you can't get to it at all. We shouldn't need the entity here. So these are just boxes. And now we want to do let distance equal strategy walk distance. This is and state, and we want to do it at I point 2. Where are we walking from at? And let's pick like this bottom left corner here. It's a good place to start walking, I think, and that's 0,3. Then we can print the matrix dist. Not create bomb map, but walk distance. VecDeck. Oh yeah, we're gonna have to use get a VecDeck. What file do I have to open for a VecDeck? Let's go back to Tron. VecDeck. And VecDeck is fortunately part of the standard set, so we don't have to worry about it not being there. Okay, so you can see the walking pattern now. These are where I put the walls in. So this is 0, 1, 2, 3, 4, 5, 6, and 0, 1, 2, 3, 4, 5, 6, 7, but also 0, 1, 2, 3, 4, 5, 6. So that fills in the walking path itself. Let's increase the size of that just so we're satisfied that it actually works and I didn't just get lucky on that one. I'll literally just copy the same thing. Let's just make it 10 by 4 and then we can just copy each of them. And I meant to have that one corner closed off. Somehow I got it screwed up though. Wait a second. 10, 11, 11, 11. So this one had one too many before on it. This is column 13. It was meant to have column 11. Okay. Let's see if we can fill up the grid on that. Alright, so we have an area blocked off, and you can see as we walk further away, it's further and further distance. So now we have the walking distance. How far is it to walk somewhere? What we want to do is we want to put a filtering thing here. We want to say if it's safe. And here I'd love to pass it a closure function, which I don't know how to do in Rust. Alright, what was the purpose of doing this again? You guys are all very quiet today. I'm focused to talking a lot on my own. So I got the A fill, but I wanted to have it, again, I wanted to have it backwards from the empty spaces to where I am. Oh, that's right. I'm going to do a breadth first search. So not distance. It's going to be a very similar algorithm that says from my current position, what is the distance to a safe spot. And so we can do the same thing instead of filling a grid up, and so I think this works fine. We proved that was correct. Now we want a function that's very similar, and again, I'm not clear on how to model this. We're going to say distance 2, and from the position, we're scanning, and okay, and it's going to return an I32, and it has to return a function, and these are really ugly in Rust, from what I recall. Rust except closure. Because Rust doesn't treat closures and functions as the same type, which is really unfortunate, which makes it really annoying to make functions that can take a function or a closure. And the easiest way is just to do a type. Okay, that's not what I want. I want a better one. Okay, Rust, pass function, pass closure to function. Server not found. Okay, how do I pass it to a function? Just tell me how to pass it. Map is an F, takes a closure of type T, returns it. Alright, that looks okay. This takes a function and it's supposed to take a I.2 and return a Boolean. And see, what I don't like about Rust is that this now only takes a closure. You couldn't, for example, have a function that takes this, but in our case, we're going to have a closure, so I'm totally okay with that. Okay, so what we want to have now is the current distance, the max distance, and let mut current distance equals 0. We're just set the current distance. Okay, now if, so we're going to use a function, if f of op.lock, then we can return current distance because we found what we wanted. This is going to be an optional I32. Might want to return a path there, but I don't care. Otherwise, we go through the standard procedure, and this is why it's really it's really weird. Is we do this return here. Otherwise, we do the standard procedure, and the current distance goes up. Oh, we just do this one. We don't have the current distance. Let's say op.distance. We don't need to keep track of that. Otherwise, we return none. And so this we can go back to the bomb map one. Where's our bomb map one? Here's the bomb map. Let's run bomb map again. It's gonna get mad at me. Yeah, expected type. I don't know how to do these damn types. Tell me the type. Well, this is from the example from the book. I know it's from a different map. So it doesn't work. Anybody know how to pass a closure to a function? Just know what I want. Anybody have an official reference? I thought I did this once before. How do I pass a closure to a function? Most useless thing. I mean, it's one of the things I'm still confused about with Rust is I don't know what paradigms it's trying to support, because it very clearly doesn't support object-oriented programming, and it makes functional programming very hard. So I'm kind of at a loss as to what the programming model is I'm supposed to be using with Rust, to be honest. Just give me anything. It should be a basic one. And it kills me. It kills me that it talks so much about closures, because the sole purpose of the closure is to pass it to another function, and they're not going to tell me what the syntax of that is. Take closures as arguments, and well, that appears to work. It takes a function to f, and this is of type f. But now we have to say a where on here, where f. I don't understand why. To me, this makes no sense. Why would I have a parametric type and then still have to say what it is? I point 32. I return a bool. So I point 2. Sorry. We want to return some op distance. Okay, so it's going to work. Now we're going to put it in the tests on this create bomb map. What we want to do is we want to say get distance 2. And this will only walk the correct places. So how do I do this now? I want to do this. I want to say let d equal strategy distance 2 given a state and a position and a function. And let's take the function. Let's take the position 9, 9. Because we're going to start there, so we have to walk at least 2. The reason we should have at least 2, and if I put a wall there, we're going to have to walk at least 1. Then we're going to have a function, we're going to have a point here. And how do I do this? Right, I want to say grid.get point equals standard I32 max. Something like that. I'm a bit unclear here. Let's just do this as print line distance d. I'm expecting a number of 2 to come out there. Whatever, do the debug formatter. Sum 2, perfect. So sum 2 is good. So if I stick a wall here, I should expect to get a sum 3. Let's stick a wall down there. And we should get a sum 3 now. Sum 3, perfect. Okay. Now, and return a none if there's no way out and it's a bad one. There's no one to safety. And now we can compare the value. And we can also break out. There's another option. We can break out early if we know for sure we die, but let's not do that. So I think we have everything we need now. This is horribly slow though, but and this goes into the can walk away. We're going to drop this whole thing here. We're going to create a bomb map. Let bomb grid equal create bomb. What's it called? Create bomb map. Map of the state. then we're going to get the distance to safety. Let safe distance equal whatever it is. Distance 2. Let's just copy it from over here. Distance 2. Becomes the distance 2 on the state, and we're going to give it the player.position. Player.position, and give it a point. It's safe if there's nothing in the bomb grid there. It's safe if it's not the bomb grid there. If safe distance that is none, let's just do a match on this. Match safe distance none, and this becomes true. If I can't find somewhere safe, then we're pretty likely to die. And otherwise we have a distance, some distance, and we're going to do this. We're going to say bombgrid.get, oops, bombgrid.get player.position is greater than the distance. That looks suspicious. Okay, so the understanding here basically is that we create the bomb grid and we check the distance from where we are to somewhere safe. And if we can walk to there before those bombs are unsafe, then that move is safe. Otherwise, we won't take that move because it's not safe. But this is an extremely expensive function now, which is going to be problematic because we can't look very far in the future then. So let's just run a test. Let's build everything and hope it works, and then we'll just submit the thing. That's good enough. They failed. We knew this one had failed. So clear and cargo build. And we haven't connected the screen yet. Okay, you should just like the file, upload file to IDE. Here we go, and let's see if this actually works. We're back to the actual game. Let's play around against these people. I just want to make sure I don't die in a chain reaction. Oh, this was a bad one though, because we weren't sure about it. It looks like we don't die because we come in second now. Oh. And that's because we don't do anything! Well, damn it. Well, it's surprising that we come in second in that case, but that's obviously an error in the algorithm. Nope, that's for leaf. Why do we do that? So... Oh, because this is wrong. This is likely die. This is supposed to be less than or equals distance, so I got those inverted. Alright. Watch me do worse. Doing nothing is still quite good, but that's how we actually got the Silver League, is just by doing nothing, blowing up one box and sitting in the corner like a coward. So we're dropping bombs. Well, let's figure out why we die then. Well, why the hell did I drop a bomb there? Huh? I dropped a bomb and killed myself. That should not have been a valid move, so we should have rejected that move. So we have to look at the logic as that we could have walked the other way. And we choose to move 10, 10. Then we chose to do bomb 9, 10. So we bomb and then go to 9, 10. We'll have to figure out why that is. Okay, likely die. What do we call likely die? It or best turn. If likely die, we return none. There's nothing there. Okay, good. Do we call it anywhere else? No. So it or best turn. We never drop bombs there, so where do we drop the bombs? Get best move. Best. What's it called? Get my best turn. We don't call it here. We don't check if it's a safe move at the top, so let's do the same thing. If, what did I say, likely die? Likely die. If likely die, and dupe state, then continue. Now it'll block us so we don't drop bombs we're about to die. We can actually probably take out this die check in the further iterations because we'll filter it out at the top level. Although we might walk into a corner, so I don't know. We'll find out. Alright, what happens now? We should see what happens now. I should probably press reload in it. So either we don't place a bomb again, or I actually place bombs, which is good. I wait till like last minute to walk away though. It's like so scary, yeah? And we wait, we go out. I don't know why I placed a bomb there though. I placed a bomb in the wrong location. That's weird. And I don't die, I just don't get many points. Okay, so I see lots of optimization we can make of what we do, but the goal here was not to die, and this is really good that we don't die. How many points do we... So it's actually, this is an interesting game to watch, because the guy's very aggressive. The other guy is just dropping bombs like a madman. And he only has slightly more boxes than us. So we have 17 to his 19. Now we placed the box in the wrong location there. That's what I'm concerned about, is that our logic for where we're placing boxes. And we're behind by 1. And it timed out. We actually would have had an actual tie there. So this is actually looking really good, unless I just got lucky on that one. Let's submit that and see what happens, though. And we're really not doing a depth very far, But if this gets us higher, that would be enough to prove we have the right approach and that the safety. All we wanted here was the safety approach. Just keep ourselves safe. That's our primary goal right now, is keep ourselves safe. Obviously, I'm not concerned if we lose them. We jumped up very fast. That's either a good sign or we got lucky. Ah, well, I might have got lucky. We dropped back down. That's not tragic yet. Let's see where we go. And like I say, we saw some fixes that we're not placing the bombs in the best location, so there's something wrong with the scoring. Ah, no, I know why it is. Because we don't get good scoring because we're not searching very deeply, I think. We jumped up again. That's a good sign, though. To go jump up and down like that's a good sign at 5%. I'm so nervous. I don't want it to go down. Ah, that's another good jump up. We're actually looking pretty good now. Let's monitor this in the leaderboard then and see what we have. We're going up. So that was a lot of little algorithmic things to get what we had for the safety thing. And if we could get that super fast, that would be a key. You'd want to call that in every iteration, but we might have to filter that out. And regardless of how we do here, our next step is to, well, we'll see how we do. Ah, we dropped again. That's not good. That's not good. Not many battles completed, but I mean, we need to keep going up. I think we're definitely better than before. And so we definitely hit a higher rank than we ever had before. We got to 37. Oh, that was a drop, though. So let's look at some of the ones where we're losing then. Let's look at the battles where we're losing and figure out if there's something simple we can do. So this one where we came in third, nobody died. We just didn't have enough points again. How far were we off? 9-9. We're really not very far off. Alright, so what about this one here? Oh, I died in this one. How did I do that? Really early in the game, too. I made the same mistake there. How did I make that mistake? He should not have placed the damn bomb. So right here, we placed the bomb. But there's something wrong with our algorithm because it should not have placed a bomb there. Because it should have detected the fact that there's no safe movement from here, because the can likely die would have failed on it. And it would not have placed the bomb. So what do we have there? Why would I have placed the bomb? Because it's right here. The likely die failed us. Likely die is wrong. Likely die failed us. Do we have to debug this? What did our map look like? There's an item, and we were right there. Wait a second. Oh crap. Haha. You know why we died in this one? Is because of this item here. I think. Whoa, maybe it's the debug mode is on. How far does this bomb go? That one covers 3 squares, so if I put one here, it would cover the next 3, so we would die. And why would we die? Why would we die there, though? Why did we consider this a safe position to be in? Well, we can actually debug this stuff now. We have tests for it. I'm not sure how to easily do that. Let's figure this one out. We can create tests, and I usually call these scenario tests. Scenario 1. Scenario 1. And we'll just get rid of these later. Let mut state equals state new I point. How big are these? I forgot how big these things are. These are 13 wide. Position 1, position 14, so these are 13 wide. These are 12 long, so 35 to 45. It's 11. 13 by 11? Is that the right number of the board size? 13 by 11. Okay, and we're going to have to make the parsing do a bit differently here. I'm going to add a few items to this. There's a bomb at 0, 1, 2, 3, 4. It has a timeout of 7 and a range of 4. There's a range of 4 at this point. I'll just ignore the other bomb. I might as well add it just in case. It doesn't matter. It shouldn't make a difference here. And this one is at 11, I think. No, that'd be 12 of a 10. 10, 8, I guess. Whatever. The boxes, and we have the parsing here. State.parse. Where's the parse? X, or let's put X because it's easier. Let's put a tilde. And I don't have a way to parse this yet, but self dot. These are actually entities. No add. Ah. entity, and what do I want to add? I want to add an entity, new entity type. This is an item. Owner doesn't matter, we're just going to call it 0. Position is going to be position, and the two parameters are going to be 0 and 0. So we're going to add an entity for those just to say that we have an item on the board. And we've got rid of the 2 stars. Those are where the bombs are. Items, we were the player. The player is at at 0,5. And we take him out of here. Alright, so let's go through this thing. We have a scenario. Let's get the bomb map. Let's do the exact same thing we had above. We have the grid, we have a great bomb map state, print the matrix, and distance 2. Let's do player position. Let's figure out where their safety is. Point, grid that gets that distance 2. Ah, crap. I want scenario 1. Oh, come on. Leave me alone. Got one. What are the entity types? Item range. Let's just call it item range for now then. We don't have to care what those are. And well, it failed. That's not good. Broken test, we have the wrong box type. Why? What do we have in here? Oh, we have those boxes. Yeah. We have an actual box. That would be helpful to know. Game box. No owner, it's at the position 0,0. We don't know what's in it, we don't care. So the bomb map looks okay, and well, curious. The distance is none. It clearly said we could not walk there. What if we say we're on the other side of the bomb? That should be safely. Distance 2. So, why is it not doing that? Why is it doing... So again, our test is actually showing that it worked. Are we getting up anywhere? No, we're stuck in the ranks because we're still dying on some things, I'm guessing. Now the question is why, if we likely die in this turn because we placed the bomb and we moved. That just screwed up. Let's look back at what our output was. Move 12,3. No, bomb 0,5. Because we decided that bombing 0,5 was 7. And I'm not clear how, because bomb 0,5 should have failed. I see why it fails. There's an item there. So if we drop a bomb, it's going to calculate. No, we bomb and move, though. It's going to calculate that we're protected by this item because it blocks it. But then we consume it immediately. For our own safety, we should probably not consider items as blocking anything. It destroys the items, but we run a very dangerous game of picking them up then. That's a tough one to deal with. Let's see why else we're losing, because that one I'm not sure is a clear failure for us. This one right here, what happens to us? We don't have enough points. Alright, not enough points. That's another one. This one I die. Well, let's check that one out. Dying. Dying's bad. But that item one sucks. Yeah, if I just don't consider that they block bombs, we might be better off. Why do we die in this one? I am red. Where am I? I'm down here. Same thing, the items. And I could have easily walked away. He just chose not to because he was close to this position he wanted to be. And play that again. Alright, so we're gonna kill this one. I'm gonna make the quick fix and see how much of a difference it makes if I just don't consider items as blocking the bombs. Create bomb map. And grid cell does not equal cell type. Item. And that'll just basically mean, let's see how much better we perform in that situation there. Oh, we win then. Interesting. So that makes a big difference. So now, do we submit? Probably. We can probably submit just because we're not climbing up fast enough. Alright, so let's just submit that. I like these initial battles where we get this big jump. There's no way we jump to 35 initially, but especially with that one loss. That looks more like it. I gotta go off to bed here soon, I think. And it is, we live dangerously. We live beside the bombs, And I know why that happens, and it's something we can fix. It's our strategy. Our strategy for where we want to go next doesn't consider the current bomb, doesn't consider any bombs, and that's something we can easily improve. And again, but we were losing mainly because of safety, and that's what we addressed today. And I want to see if just being safer gets us going higher. Right, and we put ourselves in dangerous positions. This is what I mean about the game map, the safety. We can keep improving that, so we never put ourselves in a dangerous position where the enemy can hit us. And all right, and we jumped the highest we've ever been, which is really good. Just hope we just don't fall back down there. We still have winning battles there, though, so we're okay so far. Wow, we jumped really high up. What happens to this guy here? How do we end up winning? Because we're like we're behind in crates. Unless he's just too cowardly and stays away from me. I think he's just somehow cowardly and stays away from me. Oh, we dropped again quite far. We were up there, then we dropped. Oh man, we're going to have to fix some of our scoring things. Well, let's check an easy one. Why do we lose this one? Because we just don't have enough crates at the end. It's tied, okay. This one here. We die. Let's figure out why we die in this one. That's the curious one. Why do we die here? Let's go to the point where we do something stupid. We're red over there. What happens to red? Oh, I see what happens. Well, actually, I'm not clear what happens. Can we get out of this? That's 6. 1, 2. We could have gone there. We could have gone there, and then there. Yeah, our safety check. It assumes we're unsafe right here. It assumes we don't have a way out, and it just panics. It doesn't know what to do. And that's because it gets trapped between these two, because the bomb map has both of these on it. And so it doesn't recognize that the bomb is unsafe here. Alright, so our safety check can actually do something slightly different. Where do we do that? You know, I don't know why it's doing that, because it should have found us that it should have been safe here. Oh, I'm too tired to think about this now, but it should have been safe there. So we have that one, and Let's just copy it. Let's copy to the first place where the bomb occurs. Copy. Go back to our strategies test and figure out why is it doing that. Why? And we have 2 bombs. The player is at, that's position 5, 8, I think. 8. And there's a bomb at 6, 4. And there's a bomb at 8, 8. 8, 8. And we don't know what the ranges on these things are, do we? Well, we can find out. Ours is 4. Should probably just output this. So it has a timer of 4, and this one has a timer of 8. And the other one has a range of, let's see how far that range is. 1, 2, 3, 4, 5, 6, at least 6. 6. So let's show the bomb map. And the distance to safety at the player position, let's find out what it says. Oh, we can get rid of this thing here. The player is not there. Oh yeah, and the bombs go away because we put them on somewhere else. So I got these ones backwards. It's 4 and 4 and 8, 6. And it's found a distance of none, so it's not found any safe spot. Which is really weird. If I increase this to 9, does it make a difference? Do I really not have a safe spot? Okay, no, I have an error in my algorithm here. Well, yeah, it doesn't. It's it's somewhat safe. It can't do multiple calculations as safe. This would have to be a recursive safe. It's distance 2 is going to have to return a distance, whether it's safe at that time. But no, so it's not. So it can't find the safe way out here. And this is really unfortunate. It really can't find the safe way out. So it just sits there. That's not an easy one to fix. Let's look for another one where we died. I don't want a second one. I want one where we're last. Here's one where we're last. Let's figure out why we die. Let's go right up there. What do we do funny? Alright, so we have this problem that we stick around. And we wait too long. One, two, three. And we actually had a way out there. But that was on the grid too. Ha. So it's in the grid map, and we're only checking that if it's safe at the time. How do I do that? Well, yeah, that thing has to take 2 positions. We slowly climb in the ranks, though, so we might not meet more as the distance 2. Hello, Thanos! Welcome to the show. So distance 2. Distance 2 has to change here. When we say we take some distance, we actually have to check if it actually takes the distance as well. Is that at this distance, is this actually safe? And this is really hard to do. I'm really wondering how to do that then. Because basically, it doesn't understand that this position's safe to get away from here. It has to get away from there. The position's safe, but only for a moment. But if I consider what's safe now, is I should walk towards them anyways. I should walk towards the safest distance. Ha. How do I do this? I have to pass the distance, and it has to say, is it safe? And as long as it... Yeah, Thanos, we have some calculations, but we're pretty high in Silver League. I'm having a few problems with the bombs, is that I'm not detecting when I can walk to safety. So in this position I am right here, my guy just sort of sits there. Because of the way we do our bomb mapping, is the moment this bomb is placed here, we don't consider this spot safe anymore, which means I sit here and I say, well, there's nowhere safe, let's just give up and die. And what we should be doing what should we do? I'm just trying to figure out how I can logically do this, how I can figure out where I'm supposed to be going at that time. There is a way out, but there's no safe spot he can reach. There's a safe spot here and here. These are very clearly safe. But he doesn't pass through anything, so it's like... Yeah, how do we actually do this? We're looking for there may never be a genuinely safe place. We may actually only have partially safe places. And we're looking for a spot that can we move safely. It's not like can we move to a safe spot. It's like can we move safely in this direction. And that would mean can we move safely means if we hit a genuinely safe spot, it's okay. Or if we manage to walk and not die. No, there is actually, Thanos, we can actually get to safety here. We have plenty of time to walk up, up, and to the left. We're the blue guy in the middle, so we can definitely get out of this situation. But what do? Is we just sit there. Because remember, we start at 4, and this is 3, and it ranges 3, but we only go 2. The range of this thing is only 3, so we actually had enough time to get out of there. The fact that we sit around waiting this whole time, the fact that we sit here in the dead end is also perhaps another problem. And so we have 2 approaches here. We can actually just say, do we get stuck, or we just walk away from our bomb? Why do we get stuck? I mean, the fact we let ourselves get in this horrible situation, he could just drop the bomb there and we'd actually be trapped. But he didn't do that for some reason. And so now we have the situations that we should have walked out anyways. And because we were waiting for the end to come down, is that if he didn't place that bomb, we would have actually walked out of there. And we didn't walk out of there because he placed the bomb, and that screwed up the map. And trying to think of how we can fix that map then. When we're looking to the distance 2, can we safely... We're looking for distance 2, a safe spot, and... Well, maybe I should do a double function here. Is it safe? Well, we see the whole grid. We see the absolute whole grid. That's not a problem. And I'm just trying to figure out the logic here. I think this distance 2, should actually be something different. It should actually be a safety 2. Which position is safety? Is there a safe position from there? Let's just change this to safety 2. Safety 2. Safety 2, and this is the safe function. Safe. And this is alive. It's also of type F. Are we alive and are we safe? So there's 2 different functions we're going to pass to safety 2. And we're going to say if safe, then we're okay. We're safe at that distance. Otherwise, if we're not alive at this distance. Alive, up, lock. And this actually has to take a different one. This has to be G. We have to pass the distance as well. We're going to pass the distance to it. Where G, and G is function I point 2, I32. That's a distance or time. Cool. It's a time step. If we're alive in distance, if we're not alive, then we just break out of this one. We continue as well, because this is not a safe place to go. And that's where we return none. And we just want to return a bool. We return true. No, we'll return a distance. Safe in some distance. And otherwise we return none. We're not alive. Okay. So we're going to run this strategy test here. And what do they call it? Safety 2. safety 2. And it takes another function, which is the point and time. And this is where we say grid.get point does not equal time. Then we're safe. Where am I calling that? Distance 2, distance 2. So now this is safety 2. Safety 2, the same function. I know this is hard to follow. I'm just kind of get stuck in here. Point and time. And we have the same thing. Bum grid.get point does not equal time. Is there a safety point? Yes. And we'll just make this false otherwise. It's kind of a risk. I'm not clear on this. I really should have probably checked in the code first. 113. Just go away. We don't need this one. So we're stuck at rank 30, and I really should have checked that in. Distance 2 is none, which is a problem. We still should have found a safety distance here. Oh wait, that was the other grid. Let's copy this one here. No, that one should have worked fine too. We would have found one there. We were fine. So this is a different grid we're testing. We're at here. 5, 8. 5, 8. And this bomb goes off in 4. And so if we go 1, 2, 1, 2, 3, 4. Well, I guess we have to check more outputs here. This is a stupid thing because we have times involved here now. We have I'm going to call it offset Z because we actually have to consider this one as well because we have time as a factor. So we have to consider the fact we don't move. Still distance none. No, come on. Come on, come on, come on. Well, let's see if it actually works in the situation here. I don't like it does this. This pisses me off. It has a different scenario now, I think. Man, that sucks. That's not an approach. That's not an approach. I'm going to have to rethink this approach. Let's undo this. Let's undo this. I don't like this approach. Something wrong here. Purpose of things like git. No, that one we want. That helped us a bit. And the tests here are I think the other one is that because a lot of the battles we're just actually losing scores. I have one other way we can do this. Let me get out of there. The other option we have is that when we're evaluating these things in the strategy, my best turn, looking for a good place to bomb. So we don't bomb. And where do we put good place? Yeah, we're going to the good place to bomb. What we couldn't do instead is say find a safe place and prefer safe places over the ideal place. And can we do that quickly? Can we look for a safe space? Oh man, I can't think. So that's the other option is actually, and maybe I'll do that one tomorrow night, is safe space. We'll just do the safe space one. And what I mean is that instead of sitting around in a bomb situation, is that instead of going to the ideal spots, where we do walk away from the bombs, but we could be a little bit safer and say just always walk towards a safe space. If that's going to count as points, or we change that, and I'm not entirely clear on that, but we're not likely going to make it any further right now. All right, we're done here. 19.83. That's a huge jump we have to do still to get to the top. All right, so I think that's going to be it for today. If you join a bit later, sorry I don't have much more, but I'm kind of tired at this point, and hopefully I can come back and do this a bit more tomorrow. Can't promise that, and we'll see whether I can figure that one out. But we're making progress. We were at like 150 or something. We were a lot lower, so we made progress. We definitely know we're on the right track, and we can definitely go further than that, and we're trying to solve it. Again, we're trying to solve it with a mix of heuristics and like algorithms here, and we'd like to look at a deeper depth. We don't look very far in the depth now, and that's the biggest issue, and we end up standing around doing anything right now. Otherwise, tomorrow I'll just be working on Leaf most of the day. Hopefully on Friday I can do another Leaf show, maybe about developing wormies in the morning or in the afternoon. I'll develop wormies again, and that's what I'm saying. I can't even think of what I'm saying now. So please subscribe and follow and tweet me when you can and promote the show. It really helps a lot, and I thank you very much for watching, and we'll probably see you again tomorrow night.